Okay, here's an interesting question, sort of a tougher one. It says nitric acid solution contains 71% nitric acid by mass, has a density of 1.242 grams per mil, and they want to know how many moles of nitric acid are present in 1.20 liters. Okay, so first thing I would do is, this density is something that you might have learned in another class. Density is equal to mass over volume. So if I have a density and a volume, I can figure out the mass. So just by multiplying both sides by volume, I'll get mass is equal to density times volume. And the density is 1.42 grams per milliliter times the volume. Oh no, the volume's in liters. Let's convert that to milliliters. So that'd be 1200 milliliters. So the milliliters cancel. Okay, so now on my calculator, I'm going to figure out what that's equal to. So 1.42 times 1200, 1704. So 1704 grams. So 1704, that would be the weight of that entire solution there. Okay, so then mass percent, let me figure that out. I have a mass percent formula. So mass percent is equal to the mass of the solute, and in this case it'd be the HNO3, divided by the total mass of the solution, which in this case would be that one. And what we're wanting to know is that what the mass of this HNO3 is. So again, multiplying both sides by total mass, I'll get the mass of the solute, or the HNO3, is my mass percent times by my total mass. Okay, hopefully that manipulating the formula is okay for you. So the mass percent, it says 71%, so let's convert that to a decimal, times by the total mass right there, 1704. Okay, so the mass of my solute, so I got to take that last number and go times 0.71. 1209.84. 1209.84 grams. Now notice I'm not worried about sig figs just yet. At the end I've got 3 sig figs there, 3 sig figs there, 3 sig figs there. So I'll round things to 3 sig figs at the end. Okay, that's my mass of the solute, and that is the HNO3. So now I've got a formula. Moles of anything is equal to the mass that you have of it divided by the molar mass. So the mass I have is this. So 1209.84 grams divided by the molar mass of HNO3, which I conveniently figured out. Hopefully it's still recording. Alright, so with molar mass is there. So 63.02 grams per mole. There's a decimal there. Alright, so now I have to take that number I just got and go divide 63.02, and it gives me 19.197715 moles. The grams cancel out. Rounding it to 3 sig figs, 19.2 moles. Fairly tricky question. In this test, we might do a mass percent part of that question, but I'm not going to make you know what the density and how to work with the density is. Okay, hopefully that helps with that question.